Right. It's not on though. Working, right? Yes, working. So guys, good evening. It's morning, right? Guys, good morning. So we're starting the next part of heat, the heat conduction, right? We have discussed the formula. Yeah. So shall we come to the theory back? We discussed a few things last week, right? So what did we discuss so far from the very beginning? We discussed the difference of the heat and the temperature. We discussed how the heat contains inside a material. How does the heat contains inside a material? in the form of kinetic energy, right? The collective kinetic energy of each and every molecule gives the heat of the object. You remember that, right? And we discussed about the heat capacity and the specific heat capacity, that is the amount of heat that an object can absorb, and specific heat capacity that is per unit mass. And we discussed the latent heat as well. Two of the latent heats are there under the physics, the heat physics. What are the two of the latent heats? Latent heat of fusion and latent heat of vaporization, right? Two of the heat, the latent heats are there. So what happens in the latent heat? At two of the state conversions, the temperature stays still. It remains constant until the complete conversion occurs. The temperature remains still, right? It stays still, and all the heat supplied is absorbed to break the bonds. Good, right? Good. You studied, right? Nice, good thing. You have to answer like that. You have to have that memory. That is one of a good way. You'll be safe there. So after that, we discussed the difference of evaporation and the vaporization, isn't it? We discussed that. And what is the difference between the evaporation and the vaporization mainly? The vaporization is artificial process which we have to supply the heat and take it up to the 100 degrees of Celsius if it is water, which is the boiling point, and the water will start to escape to the atmosphere as its vapor form. And in the evaporation, what happens? The molecules take the internal energy and escape the surface, and when that happens, the internal energy decreases, so the temperature of the water also going down, right? That is also decreasing. The temperature is also decreasing, but in the vaporization it isn't, right? Temperature is constant there in 100 degrees of Celsius at 1 atm of pressure, and it's a visible process. We discussed it, and the surface area doesn't affect the vaporization, but it affects the evaporation. And we discussed a few things there, right? That table. Those tables are usually coming for the exams. When I say the exams, the A-level exam. Right? Yeah, sometimes to compare, and might will ask something about the evaporation separately. When the vaporization separately, questions could be there from the table, right? So we discuss up to that, and we did the exercise 2, and I gave this question homework, isn't it? Third question homework. Answered it? No. Why, what happened? Huh? Efficiency. Oh, ඒක බලන්න. නේ? Box ගාන හොයන එක නේද? නෑ. Really? කරන්නේ දෙක. Box ගානක් හොයන ගාන exercise 1 එකේ තිබ්බ එක. Fifth one. ඒක කරාවේ නේ? You asked for the recordings. It's there. We discussed it last week. Asked for the recordings. නේ? Last week we discussed it. Now this question is one of the good questions. Now online people, did you do this? Shiny, did you answer it? Sadish, Malshi. This is one of the good questions. No, didn't answer it. That's the thing. So if I discuss it, no. Mulchi, no. Shiny. If no one, like, no, I think no one has answered it. So if no one has answered it, I'm not going to answer it as well, right? So do it at home. Otherwise, no point discussing it, because you'll be like it'll be like a storytelling. Oh, I won't do the storytelling. So you do it at home. We'll discuss it afterwards. You remind it to me. Otherwise, I'll forget. Right. And the method of heat transferring, we discussed this as well. So I told you the original format of heat is the infrared. Yeah, the original form of the heat is infrared, which is the electromagnetic wave that is coming from the sun. Usually from the heated objects, the IR are released from the heated objects usually. So it doesn't have to be the sun all the time, could be anything, but usually the heat for us is coming from the sun in the form of IR, which is the infrared, that is the electromagnetic wave, and it doesn't have to have a medium to propagate, isn't it? So it's coming to the earth, and when it comes to the earth, it grabs a molecule. So if it is a solid molecule, that the molecules are attached to each other, they are staying next, like staying close together, stuck together, so that the conduction will occur, isn't it? The heat will transfer in the form of in the type of conduction process, in the way of conduction process, if the molecules are attached together, if the molecules are close together. And if the more of the space is there, like in the liquid and the gases, if more of the space is there, what will happen? What will happen if the liquid and a gas, if the more of the space is there, the molecule will get excited. The molecule will get excited, which means that when the vibration or the kinetic energy increases when the heat is supplied, right? So when the heat is absorbed to a molecule and it has more space around it, it will get more excited and it will move with the energy, right? The particle will move with the energy. The movement of the energy with the particle from one place to another, we call it infection. What? The movement of particle absorbing the energy from one place to another is called what? Yeah, the convection. Yes, convection. No, the radiation is the original format of it. That is the electromagnetic wave. That is the electromagnetic wave. When a particle absorbs it, it gets excited, and because the kinetic energy is increasing, it's taking the molecule to another place. That the energy moving with the particle from one place to another place is convection, isn't it? Understood it? Yeah. That is convection, and the energy is still inside there. IR is still inside there, but we don't call it the radiation, because the radiation is moving without any of the particles or the medium. So if the particles are moving with the energy, that I told you the last day, right? If you say Yohasa is given the heat and she's with more of the space, with no attachments there, what happens? She gets excited, she takes the energy and moves from there to somewhere else, and she touches someone else. What happens? The energy is given to the person that you touched, and what happens to that person then? Now he gets excited as well. What happens? His kinetic energy increases. He is moving from that place to another place, taking that energy. That is called what? Convection, right? So that the particle moving from one place to another place, taking the heat, is the convection. But in convection, when the particle touches another particle, the energy transfers, right? That transfer is in which that is conduction, isn't it? When the two of the particles are touching and the heat transfers, that is conduction. So in every convection, a conduction is there, right? A conduction is there. Understand that? Yes. So every convection has a conduction as well. So those are the three of the things. So we discussed those, and conduction is the next thing, right? The heat transfer is best done by conduction through the most solids, because the solids, only in the solids the particles are attached together, right? So heat is the kinetic energy of particles. Particles of solid are tightly bound together. Therefore, heat travels from one end to the other by gradually transferring the kinetic energy of the particles to adjacent particles. Particles in liquids are not tightly bound together. Therefore, heat conduction through liquid is very poor. Water is very poor conductor. Materials that conduct heat well are called the thermal conductors, while materials that conduct heat poorly are called the insulators of heat, right? Right. So the heat conduction, now this part. වැඩිපුර තියෙන convection, but the conduction is also there in a certain level. චොට්ටි එකක් හරි තියෙනවා ඒ touch වෙනවනේ කොහෙන් හරි. එතකොට conduction එකක් තියෙනවා. But what happens more is the convection. Right. So come to this conduction part, right? So I have to discuss the equation. This part, heat conduction along a rod, right? Right. So this is one of the practical things that is done in the laboratories, and they found the the formula and the other variable factors, right? Three of the variables are there, and they made a formula using those variables. So this is what happens there. You take a conductor, right? This is a conductor, and you cover it with the insulators, right? Yeah, you cover it with the insulators, right? So you are putting two of the insulators so that the energy won't escape from the surrounding to the surrounding from the conductor, right? You are putting two of the insulators, you are covering with two of the insulators, and you are supplying the heat from one end. From this end you are supplying the heat, let's say 100 degrees of Celsius of a temperature of a heat is supplied from this end, and this end is kept at a low temperature. Let's say 0 degrees of Celsius of a temperature is kept at this point. Now there is a temperature difference. Now you know already what happens when a temperature difference is there. Yeah, the heat flows, right? So it starts to flow the heat. How does the heat flows inside the conductor? Because it's a solid? Conduction, right? So the heat will start flowing from the atom to molecule, it will start to flow like this. Now the heat is conducting here, heat is conducting, yes? Now this usually happens, right? So there is a rate, try to understand, there is a rate, like a speed or a rate, right? That is the word, rate, right? A rate that the energy flows, isn't it? There is a rate that the energy flows. Now at the beginning the rate is low because the temperature difference is there, but the energy is flowing slowly because the energy has to flow all the way through the conductor, right? So at the beginning it flows slowly, right? But we keep providing the heat, right? Let's say this is a Bunsen burner or something. So we keep providing the heat here. So the energy keeps flowing, right? And there comes a certain point, that this conductor is filled with energy. Now at the beginning it's not filled, it is slow. I said the rate is slow. Why I am telling that is, at the beginning the amount of heat inserted or entered to to the conductor and the amount of heat which is leaving the conductor or exiting the conductor are not equal. අගට යනකොට ඒ කියන්නේ දැන් මුලදී ඔව් ඔව් අපි හිතමු let's say at the beginning 10 joules are entering. Yes, but I have to explain because I am the teacher. Yeah. So the 10 joules are entering per second, isn't it? Yeah. And the amount that it exits is 5 joules per second maybe. The rates are not equal. The amount that enters and the amount that exits, or the rates that enters, the rate that exits are not equal at the beginning. And there comes a situation that the conductor is completely filled with the, right, there comes a situation that the conductor is completely filled with the heat. Now what do you understand there? When the conductor is completely saturated with the heat, now the amount of heat that enters and the amount of heat that exits. Oh. It's traveling, still it's traveling. By amount of heat that is entering and the amount of heat that is exiting at a certain time, let's say 1 second, should be equal. That is the point, right? There comes a certain point where the conductor is saturated, the amount of heat that enters and the amount of heat that exits at a certain unit time, let's say 1 second, is equal. We call that state a steady state. Get it? You call it a steady state. It's there in the tube. So it has to come to the steady state. It doesn't come all of a sudden, right? It takes time. So you can't put the, now this is the thing. We discuss the conductivity formula only under the steady state. You can apply the conductivity formula only under the steady state, right? Before coming to the steady state, you can't apply the conductivity formula. So usually if the conductivity formula is given, that is under the steady state, right? Usually in the questions, if it is given, that is under the steady state. Maybe they don't mention it, but if the values are given to calculate the conductivity using the formula, that is in the steady state, right? So the thing that you should understand, you can only put the formula in the steady state. So I'm going to make the formula. Now this is the background. The background is already made, right? You understood the background now? Yeah. So this is the steady state. We came to there. Now in the steady state, the amount of heat that flows, the rate of heat that flows is depending on or proportional to the temperature difference of the conductor, isn't it? Oh, is directly proportional, because if the temperature difference is more, the rate that the rate that the heat flow is more. Get it? If the temperature difference is more, the rate that the heat flow is more. It's like a pressure difference. More the pressure difference, more the rate. Get it? That is the first formula. Second formula is the rate at which the heat flow is proportional to the length of the object. Is it directly proportional or indirectly proportional? That is indirectly proportional. Because when the length is too much, I'm going to tell it next. Right? So the length is directly or indirectly? Indirectly proportional. I'll take the length of the conductor as D. Right? Length of the conductor is D. So this is indirectly proportional, which means when the D is increasing, the whole thing goes down, isn't it? Because it's the division. When the dividing value increases, the whole thing reduces. Do you understand that? 1 over 100 is less than 1 over 10. More it increases, more the value decreases. Yeah. So it's indirectly proportional. That's what it means, right? When the one factor is increasing, this factor is reducing. Indirectly proportional. That is the second formula. Third formula. That is the cross-sectional area Could you tell me how it is proportional to Q over T, the rate of,
Directly.
that is directly proportional because
Cannot
doesn't matter. You don't have to explain everything. Give the answer, that is enough. So what happens to the cross-sectional area increases? What happens when the cross-sectional area increases? The rate the heat flows is increasing. Yes, the rate the heat flowing is increasing. So it's directly proportional. That is to the cross-sectional area. Now you have 3 of the formulas, right? So I'm going to take these 3 of the formulas to 1. Come on. Cross-sectional area වැඩි වෙනකොට QOT වැඩි වෙන්නේද? Because there's more space, you know. So there's more space to collisions are because more less number of obstacles are there. Resistance resistance වගේ තමයි. Because in the metals, when the area is increasing, there's much of more space there, right? When the area is increasing in the metals, there's much of space there because the metals are usually made of more space. Doesn't matter. You study it back there. I padanka and watch the recordings. Recordings are given, right? So you can connect 3 of these equations to form 1, right? I'm going to form 1. So Q over T is proportional to delta T. Sorry, I'll take the A first. Is proportional to A delta theta over D, right? So the next thing is you have to make the proportional equal. How do you make a proportional equal? By multiplying a constant. Right? So the constant that I take here is K, which is the conductivity constant or the coefficient. K times A delta theta or the temperature difference over D is the formula. So this is the complete formula for the heat conductivity or rate of heat flow is equal to K times A delta theta, which is the temperature difference, over D, right? So what is K here now? What do you understand by K here? To understand what the K means, you have to isolate K, right? What does the K mean here? So the Q over T equals K times A, the temperature difference delta theta, divided by D. Yes. So I'm going to isolate K here. Now Q over T is the power, isn't it? Because Q is the energy, T is the time. Energy divided by time is what? Energy divided by time is power, right? So it's power. It's in watts. I'll put it in watts. Multiplied by D, that is in meters, divided by A, that is in square meters, and divide by the temperature, that is in kelvins, equal the K. Now this is the these are the units. M to M cancels out. So the K, the constant, the conductivity constant, is watt per meter per Kelvin, isn't it? Now these are the units of conductivity. So what does the conductivity says here? The rate of heat flow per 1 square meter length and 1 Kelvin temperature difference, or the rate of heat flow per unit length per unit temperature. Get it? That is the K, conductivity, right? The rate of heat flow per length per temperature, right? Per temperature, per length, how much of a rate of heat is flowing is the K. So that K only changes when the material or the substance changes, right? K is a constant of depending on the substance, right? Right. So that is K, and we have the . right. So yeah. අපි ඒ ටික define කරගමු. අරට ගියේද? අරකේද? W කියලා ගත්තා අපි rate of heat flow because it's a power හින්දා තමයි මම watts කියන එක තමයි W කියලා ගත්තේ. That's in unit it's watt, right? So it's not this. It's this. මේ Q over T කියන්නේ joules over time, that is watt. Base minus 1. Yes. Right. So if we define the terms here, what is Q over T? What is Q over T? Yeah, rate of heat flow, right? Q over T is what? Q over T is rate of flow of heat, right? And K is what? Heat conductivity. You can call it the heat conductivity coefficient or the heat conductivity constant, something is enough. And A is what? A is cross-sectional area, right? A is cross-sectional area, and theta 1 minus theta 2 is the temperature difference, and the d is the length, right? And in some cases you can take the temperature difference over length as 1 unit. You can take the temperature difference over length as 1 unit and you call it what? Huh? Kelvin. No, I'm asking like not in the units. What does it mean? Temperature difference over length, you can take it as the, what do you get there? The temperature difference and a length. The temperature changing through the no, this is a new one. The temperature changing through the length, right? Temperature changing through the length is the temperature gradient through the length, isn't it? Temperature gradient, like the temperature is changing through the conducting length. So that's the temperature gradient, isn't it? Gradient is a slope. In the graphs අපි ගන්න gradient ගන්න අර මෙහෙමනේ එන්න change වෙන එක gradient එකක් නේ. So it's a temperature gradient, isn't it? නැද්ද? You tell me now. Isn't it a temperature gradient? Now temperature is changing through the length. Huh? So it's a temperature gradient through the length. It is. Right? So you can take the whole thing as 1. Delta theta over D as the temperature gradient. Through length. නේ මෙන්න මෙහෙම තනි එකකට ගන්න පුළුවන්. Temperature gradient through length කියලා ගන්න පුළුවන්. You can consider it that way. Right? එහෙම කිව්වම තේරෙන්නේ නැහැ. That is ඒකේ තේරෙන්නේ කියන්නේ මෙහෙමයි. එතන ලොකුට තේරුම් ගන්න කියලා දෙයක් නැහැ. There's something new to know. New detail. Something you have to unlock something new. Yeah. It's like you tasted a sort of taste for the first time. Only then you understood it. Likewise, it's a new knowledge. So you have to take it that way. Not all the things will be the things that you know. But usually it's easy to understand something that you don't know using the things that you know. Right? If there's something to understand, the easiest way to understand it is to understand it using the things that you know. Huh? Yeah. So likewise, these are not all yours. Graphs මතක නැහැ කියලාද කියන්නේ? Doesn't matter, you just have a slight knowledge. Doesn't matter. Leave it now. You have it for the first time you are asking. Okay. First time you are hearing. So it's a new knowledge. Take it as that. Yeah. Right. So is the temperature gradient through the length, or the temperature changing through the length? Simply. Right. Where K is proportionally constant, it is called the thermal conductivity. The unit of K are watts per meter per Kelvin. Here K is a measure of material's ability to conduct heat, right? So the K is a measure of ability to conduct the heat. Conduction of heat varies from material to material. Due to this, the thermal conductivity values also varies from material to material. So it's one of the constant depending on the substance or the material, right? So the conduction of heat plays a useful role in everyday life. So these are the few of the examples where the conduction happens, applying a metal plate to the bottom of the electric iron. So the more conductivity is there, so the more heat will easily transfer, right? Using the thin metal pans for cooking, a wall of tile consists of thick clay walls. Since the clay is a thermal insulator and the wall is thick, heat loss by conduction is reduced. That is why the thick walls are there, to reduce the conduction. That is in the usually the cold countries, right? Like the where the ice is there, right? So the heat won't waste, right? A thick wall and some of those countries, they make the walls with a vacuum in the middle. They make a vacuum in the middle, or they fill the air in the middle. So what happens there is the heat is lost through the conduction mostly in the walls and everything, right? If the conduction occurs, the heat is like rapidly wasted, like it will go like really fast. But if you made a space in the walls with air filled in it, or the vacuum, the better, right? The conduction will, yeah, so the heat will stop, decaying to the environment. Get it? So some sort of things are there, right? Now come to the exercise. You have to know how to apply the equation here. So the first question is easy, that is of the theory, right? And try to apply for the the first two questions. Now you try it first, then I'll do it. Try it by yourself. So when you struggle, then only your brain will ready to to absorb the new things. So first one is easy. And Pinuji, if you are joining, there is a seminar on Thursday. May Thursday. Area ne. Force seminar ki vara. Force awulan ne newata. Area volume trick. Then you have the question bank one. Kara dete. Kara. Awulan ne. කරලා බලන්න ඒක. පුළුවන් නම් ඔයගොල්ලන්. මොනවාද?
40 cm.
Oh. Should be in meters. Finish?
Calculator.
ඔය ෆෝන් එකනේ. Shiny, got any answers? Malshi, Sadesh. And Shinal. Any answers? And you read the theory note back again at home, because I'm not telling, like, I'm not reading the whole theory note in the class, because like much of the things, they are the additional knowledge. I'm not saying much of the things are like additional, that they are needed. I'm explaining it, but I'm not reading it, so better you read it by yourself. I'm explaining the whole thing, all the data that in the tute, I'm explaining it, but I'm not reading the tute. So read it. First 1.0, first another. 1 is the first answer, 2 the fourth answer. Okay. 55 and 1 first answer. Okay, 2 the fourth answer. Is it 1 for the first question? It's not, isn't it? Now, what is the answer for the first question? 2, right? Shiny got something confused there. Oh, the answers are not clear. Screen is not that. Yeah, that's why. Okay.
Calculator and
Buy one. What was this clear? Yeah, second one. Done, finish. Bro, what are you doing? Use the calculator, do the simplify, don't try to do it here. Did you apply it correct to the final formula? Shall I do it? What this? Use a proper calculator for that. Finish? Huh? Not finished yet? Taking so long. Now this is just a simple application of the formula. Oh, this is the basic. What happened to the text messages? Shall I do it? Please. Still trying. It doesn't matter, it takes time, I know it, but finish. Hmm? We'll see. Hurry. Now the first question asked is 2, isn't it? So it's the 2. Watts per meter per Celsius, or the correct should be the Kelvin. If it is in Celsius, even that is fine. Second one end of a uniform aluminium rod of diameter 2 cm and length 40 cm is kept at 360 degrees of Celsius, and the other end is kept in water at 10 degrees of Celsius. The rate of heat flow through the rod is, the thermal conductivity of the aluminium is 200. So you simply have to put the formula, that's all. So Q over T equals Ka times delta theta over D, right, is the formula to apply. So they are asking for the rate of heat flow, which is a Q over T, right? You have to find this. Simplifying, K is 200, isn't it? Yeah, it's 200. What did you apply? 2000.
200
Yeah, now what did you apply? You were so surprised, and I'm telling 200. Surely you have applied 2000 or something. It's 200 into A is a cross-sectional area, so it has given a diameter, so it should be pi r square, right? So it should be pi r square, so 722, r is diameter, that is radius is 1, and it's in centimeters, you have to convert it into meters, that is divided by 100, and it's square, right? Pi r square. And delta theta is the temperature difference. What is the temperature difference given here? This is 10 degrees, that is 360 degrees. So 360 minus 10, that is the temperature difference. The whole thing should be divided by the length, which is 40 centimeters. So if I divide the whole thing by 40 centimeters is given, so you have to convert it into 40 meters, that is by dividing by 100, right? So if I divide this by 100, the 100 will go to the top because it's reciprocal, isn't it? So I'm taking it to the top, multiplying the whole thing by 100. Yes. So you have to simplify this. How does it simplify here? 40 times 5, right? And rest of the other things you will have to simplify. Now this is 100 square, one of the 100 will cancel out. So there is 100 left. 1 over 100 is left, right? And what is left on the top? That is 5 into 22 into 350 in the top. Pen isn't 350 divide by, what are they in the bottom? 7 into 100. That's all, right? Can somebody divide it for me? I can do it. 7 times 5, 10, 0 to 0 cancels out. 5 times 5 is 25. 25 into 22. 25 into 22 is how much? 1 divided by 10, that is 55. So the answer is 55. Shiny is correct. Shiny, you are correct. 55. Ready? What happened? Huh? Stuck somewhere. Where? It's like the simplification errors. That you have to overcome. because a lot of simplifications are there in the best part to overcome the simplification is the area and volume. Madi. Yeah. Area volume තමයි simplifications හදාගන්න හොඳම කෑම. Because like many more of the simplifications are there in area volume. Search වලට convert කරන්න ගොඩක් තියෙනවා. Best thing is that. Right. So the next questions you do at home we'll be discussing, right? All the rest do it at home. We'll be discussing. We only discuss 2 of the questions, right? Right. Rest you do it at home. We'll discuss it. You try it at home, and remind me to do it in the class. Right. Next thing, convection. What happened? Yeah, convection. So the convection we discussed this. What happens in the convection? What happens in the convection? We discussed this. In the convection, what happens is when your like the particles are staying with more of the space, not the solids, like the liquids and the gases. They are there with much more of a space around. They are not attached to any of the molecules that are surrounded, isn't it? Much of a space is there. So now we know that when the heat is absorbed, what happens? The kinetic energy increases. So when the kinetic energy increases, if it doesn't have any of the other molecules next to it to transfer it, what happens? It gets more excited and it moves on in the space, right? Taking the kinetic energy. So that movement from like absorbing the kinetic energy or the heat, movement from that place to another place is called the convection, and that is one of the like apart from that there's many of the things that happens due to the convection, right? So if you see this in a beaker, that would be something like this, right? A particle here absorbs the heat and it increases its kinetic energy and going up like this, and in the top what happens there? They releases the heat, right? They releases the heat. So when the heat is released, they are losing the kinetic energy, right? They are becoming neutral. And what happens now? It comes back to the bottom, and again when it comes to the bottom, it again absorbs the energy and again goes to the top and releases the energy at the top and is coming back, right? You call this a convection current. You call this a convection current. It happens this way, like මේ පැත්තට convection current එකක් යනවා එකක්, අනිත් පැත්තට convection current එකක් යනවා. එතන මෙතනදී තාපහු මෙයා heat එක release කරනවා. Release කරලා ආපහු මෙතනට එනවා. Have you seen have you cooked dal or something? Do you know? Should, but have you? Really? What happens when you are cooking the dal? Huh? Do you see the do you see the dal these particles coming top and going back, circulating inside the curry? But I haven't seen. I saw it in a dal curry. That's why I'm telling it here. Dal curry එක ගොඩ particles තියෙනවානේ. Particles are rotating really fast. If you look at it, it's the convection currents that happening there. නේ ඒක හොඳට බැලුවොත් පේන convection current එකක් යන්නේ. ඒක කැරක් ඉන්නවා curry එක ඇතුලේ නේ. බත් එකේ මම ඒක එච්චර දැකලා නැහැ. Haven't noticed it much. But in the dal curry, because in rice we don't make the curry, they usually sees in a liquid medium. That is why I saw it in the curry, because it's more of a liquid medium. So the dal keeps rotating in the convection currents, right? This we call the convection currents. Now because of this convection currents, right, that is the one of the main reason we have the seasonal rains. Like if we hadn't had the convection currents, we won't be having any of the rains. Why? Because in some of the seasons the sun is rising to the one of the deserts here. I can't remember the history now. That is something geology or something. I can't remember now. Not geology. I studied it in your, like not in your age. I studied in like me grade 10 or 9, right? In a certain season, the sun is rising to the one of the deserts there. So what usually happens when uh, in the desert areas, there's less amount of atmosphere is there, right? Because when it's heating up, the atmosphere is losing its density and is rising, right? So when the air is rising up, the pressure in that deserted area is increasing or decreasing. When the sun rises to a desert, what happens there is the air molecules are absorbing the heat and they rise up. They are going up. So what happened to the air atmospheric pressure in that area? Is it increasing or decreasing? Oh, desert එක හරි. Yeah. යට හරියේ තියෙන pressure එක decrease වෙනවා. ඇයි atmospheric pressure එක දෙන atmosphere එකකින්. When the atmosphere is lost, the pressure is decreasing. That's a vacuum pressure. That's a vacuum pressure. Vacuum pressure is a negative pressure. Negative pressure is there. So the actual pressure is decreasing because no atmosphere is there. And in the Arctic areas or the sea areas, you don't have to tell everything. You go, doesn't matter, right? In the Arctic areas, so when in those days when the sun is rising, in the Arctic areas there is much more of the water vapors there because it's one of the seas, isn't it? So much more of water vapors are there, and the atmosphere is also there. So they have much more of atmosphere. So their atmospheric pressure is high, isn't it? The atmospheric pressure is high. So when there is atmospheric pressure difference, now anywhere when the pressure difference is there, what happens? The things start to flow through the pressure difference, isn't it? So from the high atmospheric pressure with the saturated water molecules in it, because it's in the sea, the air starts to move from high pressure to the low pressure to the desert area. So a wind current is flowing from Arctic area to the desert area because of the pressure difference. And what happens here, because when the airflow is happening through the country, like through our island, and there's this what do you call this? The mountain areas. Yeah, we have these mountain areas in the middle part of the country. Yeah, the hill countries. No, there's a proper term for that. I can't remember. But when the currents are flowing through these mountain areas in the middle of the country, it gets dense. You understand that the air gets dense. Now usually the air now this flowing is the clouds, right? So the clouds gets dense and it starts to rain. ඒකෙන් පාර්ට් එකක් තමයි. ඒ කියන්නේ land breeze sea breeze එක වෙන්නේ land එකයි sea එක අතර විතරනේ. මේක ඊට වඩා කරන්ට් මේ air flow එකක් ලොකු area එකක. එතකොට මේ air flow එකකින් හින්දා තමයි අපිට ඇත්තටම මේ වැස්ස ඉන්නේ. That is why we get the seasonal raining because ඒක වෙන්නේ season එකකදී. ඒ ගොඩාක් ඊට පායනවා desert එකට Arctic sea එකේ තියෙන මේ air saturated water saturated air එකේ pressure එක වැඩි වෙනවා. ඊට පස්සේ air flow එකක් එනවා, right? So that also happens in the air breeze and sea breeze as well, right? That is what I'm going to discuss now. So air breeze and sea breeze are there. Land breeze and sea breeze are there. So right, what happens there? Now let's say when you start a job and you earned few millions, ne? Why? I'm looking forward to earn millions, no? How much you want? Let's say Penny J's earned few $1 million, and when usually the celebrities are making houses, they choose, you know, the beach areas. Not in Sri Lanka, but in other countries, they select the beach areas. Why? There's a good view. So it's relaxing, isn't it? So they mostly select the beach areas, but in Sri Lanka, if you choose a beach area, that's a different case. But let's say you are in Florida or somewhere, ne? You earn a few of the millions, and you make a house. Now this is Pennage's house, right? And this is the sea, right? And sun rises. What happens here now? When the sun is rising, the water is heating slowly, isn't it? Water is heating slowly. It takes time to heat, right? So the temperature rise is relatively less. The ground is absorbing more heat. Like the ground is like heating fast rather than absorbing more heat. The ground is heating fast, so its temperature is rising faster. So here its temperature is rising faster, and when the temperature is rising faster, the air in the ground is expanding and it leaves the ground surface, isn't it? The air is expanding here, so it leaves the ground surface, right? Because when the expansion occurs, it becomes more light in weight, isn't it? Because the density decreases. Yeah, because when the expansion occurs, the volume increases, therefore the density decreases, because the density is mass over volume. So when the volume increases, or when it expands, the density decreases. So decreased density means it's flowing up, right? The air goes up, means the air is removed from the surface, the land surface. So what happens to the land surface pressure of air is decreasing, isn't it? Because the air is removed now. So there is no air. No air means low pressure. We call it a negative pressure or a vacuum pressure. So the pressure is wait, it still didn't come. The pressure is decreasing. Yeah, relatively the temperature here is not rise much, because it takes time to, you know, heat the water, right? So the temperature isn't rising up really fast. Therefore the air is also not that hot, or is not also absorbing much of the heat and expands relatively. This doesn't expand much, right? Because the temperature is less. So what happens there? The air density here is more. So the air pressure is also high, isn't it? The air pressure is high. The temperature is low, air pressure is high. Now there is a high air pressure here, atmospheric pressure there, and a low atmospheric pressure in the ground. Now what happens? The current flow is always from the high pressure to low pressure. So the air flows from high pressure to low pressure. So when the Penage is at home in the daytime, what do you feel? The free sea breeze, that the air that is coming from the sea, isn't it? You feel the sea breeze. You are breathing you are inhaling the sea breeze with the salts. Yes. So you are feeling the sea breeze. Yes, right. And when it comes to the night time, what happens at the night time? Now it's a different case when it comes to the night time. Now let's say Penage is spending the night at that place. Yeah, and now the moon is there, right? Not the sun. No, it's the moon. The water has heated up in the daytime, and since water has a greater heat capacity, it heats slowly and it releases the heat slowly as well. So what happens now? The water is more heated and it releases the heat very slowly. So its temperature is really high. Yes. So because the temperature is high, the air close to the sea surface is expanding and is kept away from the surface. Understood it? And relatively the ground, what happens here? In the ground, the temperature rises really fast and temperature decreases really fast as well. Yeah, yeah, because it's like it can't contain much of heat. So because of that, its temperature is really low relatively. So the air isn't expand much. So it's more of air in the ground now. Yes. So that means high pressure, isn't it? High air pressure. Here it's low air pressure, isn't it? So what happens? Always from high pressure to low pressure, the current happens, right? So the air flows from ground to the where? Sea. You call it the land breeze, right? So in the night, what would you feel? You feel the land breeze, yes. And then if you are wanting to go to let's say fishing, let's say doing fishing, how you should go at night, ne? Because it's easy to go. So usually the one who are doing the fishery things, they go at night, right? දවල්ට ගිය මොකද වෙන්නේ? ආපහු ගෙදර එනවා. යන්න හම්බෙන්නේ. And because the sea breeze එක තියෙන්නේ දවල්ට, land breeze එක තියෙන්නේ රැට. අනිත් පැත්තට. So these are the land breeze and sea breeze, right? Understood it? Nice. So it happens due to the convection currents, isn't it? It's one of the convection, right? Right. Sea breeze and the land breeze. Read it. You can understand it easily. Natural convection and the artificial convection are also there. Now the natural convection and the artificial convection are like, the natural convection occurs due to like the sea breeze and land breeze are like the natural ones. The artificial ones are that if you are using a pan or something to as a a cooling support, there is a artificial convection that you create there. Artificial convection, right? So there is the only difference, right? Come to the radiation now. What is radiation? We discussed it. That is the original format of yes, fan එක කියන්නේ artificial convection එක. නේ? Fan එක. Fan you mean, right? Fan එක artificial convection. Right? What happens in the radiation now? We discussed this. What is radiation and what happens there in the radiation? Radiation is the original format of heat. Yeah? Original format in the sense it's the it's a electromagnetic wave, because all the energy formats are there in the wave format, right? If it is an energy, that is in the wave format. So the wave format of heat energy is infrared, right? It is an infrared. So usually this original format, which is the electromagnetic wave, doesn't have to have a bro, you shift the place. Bro have so many questions and troubles in the class, right? You find your own solution. You don't have to tell everything to me, right? You have to be your own, right? So what happens in the radiation is like radiation is the original format of heat, which is an electromagnetic wave, and doesn't have to have a medium to propagate. Do you understand that? Doesn't have to have a medium to propagate. So when the heat is coming from the sun to the earth, what happens there? It propagates through a vacuum. No, infrared itself is the radiation, heat radiation. You can heat again infrared. That is the original format. When it goes inside to the particles, that is when the convection and conduction happens. Yes. So with the particles, convection is there. The original thing, the solar part of heat is what? Is the radiation, which is the infrared, right? So this radiation, rate of radiation is depending on three things, right? Rate of radiation, how much it radiates, is depending on three things. One is temperature. So higher the temperature, it's actually the temperature difference. Higher the temperature difference, higher the radiation, right? There's like when we say the rate of radiation, there's two things, right? When we call the rate of radiation, there's two things. One is, what do you understand when you say the rate of radiation? Do you always understand it as an emission? Is it only emission when you call the radiation? පිට කරන එක we call the emission.
Flow එකනේ.
No. What I'm trying to ask is it only the emission? No, it's absorption as well. When it calls a radiation, rate of radiation is rate of emission of radiation and rate of absorption of radiation as well. So two of the things are there. Rate of emission of radiation and the rate of absorption of radiation is also there. So two of the things are increasing when the temperature difference is there, right? And the second thing is area. So more the surface area, if there is more surface area, the rate that the radiation can absorb and the rate that the radiation can emit is less or more. When more surface area is there, the rate that the radiation emit and the rate that the radiation absorb. Yes. Give an example. Simple example is the radiator of your vehicle, right? What happens in the radiator now? In a radiator, what happens there is, there's a coolant. Have you seen a radiator before? No? ET people? You'll be seeing it in the future. You tell, yes, he will show. So there's a coolant system. Oh, how? Coolant system that the coolant liquid is flowing and it takes the heat from the engine. Let's say now this is the coolant and it takes the heat from the engine. හරිද? මේක ලික්විඩ් එකක් විදියට එන්නේ. එතකොට මොකද වෙන්නේ? එයා මෙන්න මෙහෙම කූලන්ට් එක මේ විදියට ෆ්ලෝ වෙනවා. කූලන්ට් එක ෆ්ලෝ වෙනකොට එයා මෙතනින් එනකොට හීට් එක අරගෙන ඉන්නේ කූලන්ට් එකේ. Nah, forget that part. Listen to this one. Right? So there's a radiator here. Radiator එකෙන් කරලා තියෙන්නේ මෙයාගේ surface area එක වැඩි කරලා පිටිපස්සෙන් දානවා ෆෑන් එකක්. හරි. දැන් මොකද වෙන්නේ? surface area එක වැඩි කරලා ෆෑන් එකක් දැම්මම පස්සේ අර heat එක ඔක්කොම emit වෙන්න ගන්නවා එළියට. Right? So the coolant is cooling down now. Get it? And again the cool vecha coolant එක going back to the engine, take the heat back from the engine and takes the heat from the engine back again flows to the radiator, and in the radiator heat emission is happening, so the heat is removing and the coolant comes back to the engine back again. So that is what happens in a coolant system of an engine, right? So this radiator is made with more area to increase what? To increase the emission of radiation, right? Emit කරන්න ඕනේ absorb කරලා හරියන්නේ to increase the emission. Get it? Right. And the next thing.
ඒක ටික වැඩි කරලා යන එකත් මේකද නේ. මේක මේ අර යටට අර බටේ ටික වැඩි වුණාමත් අර ඒකේ
පොළ. ඔව්. ඒ කියන්නේ දිග වැඩි කියන්නේ කූලන්ට් එක ගොඩක් තියෙනවා කියන එකනේ. එතකොට ඉතින් වැඩි හීට් එකක් අර ගන්න පුළුවන්. අරගෙන අයින් කරන්න පුළුවන්. Right? The next thing is nature of the surface. Now this is what you have to remember. Higher the surface area, higher the emission, higher the absorption, means higher the rate of heat heat radiation, right? Higher the rate of heat radiation. Next thing is the surface area. There is like two of the surface areas. Sorry, not the surface area. The nature of the surface. The next thing is the nature of the surface. There's two of the things that you should consider when it comes to the nature of the surface, right? One thing is the nature of the surface. If the surface is black, try to understand this. If the surface is black, higher the absorbency, higher the emission, right? So in that case, if you wear a black sort of a dress and you go in the sun, what happens? You feel more heated up, isn't it? Because the black is absorbing much more heat, right? And even the skin could do that. Huh? But it's a good thing because you can convert it into vitamin D or something. Yes, so it's a good thing. And even the emission, same. If you are wearing a black in the night, where you are more heated, like you have more temperature than the surrounding. Now what happens? You feel more cold, isn't it? Yeah. If you are wearing a black in the cold area, in a cold somewhere, you are more heated up than the surrounding, so you are emitting more heat from that black. So you don't wear the black in the daytime at the sun, and you don't wear the black if the if it's too cold in the surrounding, right? Because you will start emitting and start absorbing more. ඇයි සීතල වෙනවනේ? ඉතින් හීට් එක එමිට් කරාම ආ සීතල වෙනවනේ. යා. නේ? ඒතර කළු වෙනන් ඉදියොත් සීතල පැති වල වැඩිපුර කූල් වෙනවා. දවල්ට කළු වෙනන් ගියොත් වැඩිපුර heat වෙනවා. That happens, right? The other thing is the rough surface. Rough surfaces, what happens? Would it absorb more heat or not? The rough surfaces actually absorb more heat because if it's smooth, right? If it's smooth, it reflects, isn't it? It reflects. If it reflects, that means it doesn't absorb heat. Yeah. So the rough surfaces, they absorb much more heat than the smooth surfaces, right? So if you have like rough surface, that means you will absorb much more of a heat, ne? The people with the pimples and all that things, they absorb more of the heat, isn't it? You don't have pimples, right? So you reflect. But not that rough surface of a face. Yeah?
Absorb heat and that looks like an oily skin.
I was kidding about the pimples, man. That's a rough surface, doesn't much absorb. I don't think the skin absorbs much, is it? It can happen, but yeah, if the surface is more rough, yeah, it definitely will absorb like relatively more heat. Just do research on that when you go to the university. If the pimple surface absorbs more heat than the other surfaces, yeah. So you apply something, you find a product to smooth the surface, so won't get heated up when you are going in the sun. Can come up with a new product. What would you propose? What would you propose for the name for the product? To reduce the surface, to make it cool, the surface from the sun. Something you come up with an idea in me. It's not actually much of affecting, isn't it? For the pimples, no. But for the surfaces, let's say a wall. If we made this wall, the front wall, very rough, and the sun is directly landing on it, so that surface will heat really, it will heat really high, isn't it? And if we make this more smooth, what happens? The people on the road will affect. How? Because it reflects, isn't it? It will reflect. And the people in the ground and the one who are going in the road, they will get affected. Oh yeah, there's one building that the engineers made. You doesn't have to tell everything, man. You just listen. Right? We'll have a conversation later. We'll go for a coffee and we'll discuss all that. You don't have to tell it in the class, right? What you are smiling at? Now there's one of the buildings that was made there with the glasses. Yeah. So what happens there is the temperature in the road all of a sudden increased 45 degrees or 50 in the daytime after the building was made. Huh? Not in Sri Lanka, in some of Arabic country or somewhere. They made all the walls with the glasses. That's what they did. That's what they did, and they tilted it a little bit. So the reflection heat directly goes to the road. You know, once the building was made, all the roads were heated up to 40 to 45 degrees or 50 or something. So they had to remove the building. That happened. Yeah. So the smooth surfaces, they reflect the heat. They don't absorb the heat, right? So the rough surfaces, they absorb more of the heat. That is about the surface, right? And we know already about the temperature. Higher the temperature, higher the emission, isn't it? And the solar oven. This solar oven, you maybe have learned it back in the grade 8, 9, 10 somewhere, no? Solar ovens. That you make a concave mirror and put a container in the center of the mirror. So when the sunlight hits the mirror, all the heat is reflecting to the center, so you can put a container there to heat things. You know, if you want to heat the water and everything, haven't you like come through that theory? Never? It was there in the grade 7, 8 or something. Huh? So you take a concave mirror, you take a concave mirror, and when all the sunlights are landing on the mirror, it will reflect to the center, isn't it? That's what the concave mirrors does. It take all the the reflection to the center. Yes. So the reflection means the heat waves as well. Apart from the light, the heat is also reflected and centered to the very center of the concave mirror. And you put a container here, maybe a pan or something, and you put an egg here, you can boil it, because it's heating up. That is one of the things that you came through the grade 7, 8 or somewhere, no? Never did this?
Something related to solar, but solar continues.
No? Tibur? Hi, Edi. It's grade 6. You didn't go school at grade 6 or something? Huh? Thermos flask was there. Yes. So the thermos flask is one of the one of the greatest inventions in the history. Why? Because before it found, so the water you had to heat it, consume it, then you can't keep it for a long time. You can't heat the water and keep it for a long time. You have to heat it every day when you need it, isn't it? So all of a sudden a random person finds something that can keep the heat for days. How would you feel by that time? Feel amazed, isn't it? So it's a magic. Why? You can keep the heat for few of the days, without doing anything. So it's a magic there by that time. So but when it comes to this time, this year, it's really a simple thing. But at that time it's a big thing, and the one who found it, the scientist, he just only considered 3 things. But what are the 3 things? That's why the scientists are there. Like, that's why you are also there. Why? You are all learning the things so that you will be doing much more of the inventions, right? So when this science, even like in your graduation, you will have to find something new. Otherwise, they won't graduate you, because in the final year you have to find this is a research for yourself.
Science people.
Now for you are also the science people. You are technology people.
I'm into IT degree.
Even if you are doing IT degree, still you have to do a finding in the 4th year. Yeah. because all the technology degrees are 4 years. So in the fourth year, what you have to do is you have to do a finding. You will, right? So now this is a thing. So the scientist who found it, he only thought about 3 things, because there's only 3 ways of heat can escape, isn't it? There's only 3 ways of heat can escape. What are the 3 ways? Conduction, convection, and so he stopped 3 of the ways. So the heat remains. Yeah, that is simple as that. Or he thought of it. So what did he do? So he made a vacuum here. Have you seen this bottle inside the thermoflask? There's a like silver plated glassy bottle there. And have you seen like there's a patch there? Sealed patch is also there in the bottom. Like a melted glassy thing in the bottom is there. You check your thermoflask and break it, your mother will kill you, because that is the vacuum seal, you know. So what they do is they take all the gas in this area, take it out, and you seal it. That is a vacuum seal. If you break it, there's no use of it, right? So you vacuum it and put a seal there. Why is it vacuumed? So the conduction is stopped, right? So what happens is now the water is there, because there's this vacuum, the conduction can't go through, so the heat remains inside, right? So the conduction is stopped there. The other thing, there's a bottle cap here, right? There's a bottle cap here in the top. Because of the bottle cap, the convection is stopped. Why? The convection or the heated particles can't go to the surrounding, taking the heat from the bottle or the surface. Yes, I'm coming to that point. So this is convection, right? So convection is stopped using the bottle cap, isn't it? So 2 ways is stopped. The third way is the radiation. How do you stop the radiation? There's a silver mirror inside it. If you open the bottle, it's one of the silver plated bottles inside, a glassy bottle. That silver mirror reflects the heat, right? Reflects the heat. It can't go. It reflects the heat, right? The silver mirror is reflecting the heat that it radiates. Get it? The heat that radiates is reflected by that silver plated mirror. So all the 3 of heat escaping from the water is stopped by using 3 of the different methods. One is making a vacuum to stop the conduction, and putting a bottle cap to stop the convection, and plating it with the silver mirror to stop the radiation. Simple as that, isn't it? Simple. Kaling hitala naha, that's the issue. There are so much of simple things like that none of the people have thought of. So you have to think about it, isn't it? That is what that will be the difference of a technologist and a technician, right? I'm not insulting the technicians. What I'm saying is a technologist is one person who's more with the understanding of the scientific knowledge. He can change things. He know what happens there. If something happens, he just not only follows the things, he thinks it and he rethinks it, reconstructs it, can change it, can make the new things. That is the technologist, right? So you have to have the knowledge. That is why you are learning the scientific things. So you can think of the new things, isn't it? You can think of the things that aren't found yet, things that aren't invented yet. You'll be facing many of you'll be experiencing many of the scientific processes there in engineering technology and even in BST as well. You'll be facing many of the functioning things, right? You'll be learning many of the new things, processes, aren't you? You are learning processes, right? In engineering, you are learning processes, how the mechanism works in a vehicle, no? How the mechanisms work in a uh, electric grid in a circuit. Sort of all the mechanisms you are learning. And even in BST, you'll be learning much of the processes, doing things like laboratory things, tissue cultures, right, plantations, like sort of many of the processes are you are learning. But if you don't know the science behind it, right, you can't make a difference there. Why? If you only know the processes, that is, you are only following it, right? That is, you are only following the instructions. But if you know the science behind it, the major difference is what? You can change it. If things change, you can fix it as well, because you know it, and you can invent the new things. That is the difference of a technologist, right? So you have to become a technologist, not someone who follows the things, right? So try to be one. To be one, you have to learn, isn't it? Yeah. So you're going to be what? You're going to be what? Yeah, you're going to be a technologist. You're going to be an IT person, right? Okay. Right. So read through it. And the next part is the thermal expansion, right? This is again one of the beautiful theories, thermal expansion. So we already know a bit about the thermal expansion. What do we know about the thermal expansion? Today I am trying to keep my voice low, because if I speak loud, it will start to irritate the throat, and I will start to cough. Huh? Okay, then okay. No worries. Right. Right. So the thermal expansion, what happens in the thermal expansion? We discussed it. What happens in the thermal expansion? Does the heat expand things? It does. How it happens? No. Can you build a theory back? Huh? Huh. Yeah, the molecules start to dance. Yes. So. Huh. Yes, because of the vibration, it takes more space to vibrate, isn't it? So it's pushing the other things away when it's vibrating, isn't it? Right. So when the heat is supplied to an object, the internal energy or the kinetic energy of the molecules is increasing. So the molecules start to dance rapidly, making much more space around it, isn't it? When it's vibrating more, it needs more space to vibrate, isn't it? So making much more space, making much more gaps between the molecules, make it expand, isn't it? So that is how the expansion occurs, because of the increased vibration, right? So this expansion happens in three ways to an object. What are the three ways that it expands? One is the linear expansion, or the expansion of the length increasement. Second thing is area expansion, the expansion of the area. If I take an area, if the length increases, that means the breadth and the length are increasing, that means the area is also increasing. And the third thing, if the area is increasing and the length again is increasing, that is area, thickness, that is volume. So yeah, the volume is also expanding, though altogether the three of the length, area and volume are increasing. So we have to consider these as three expansions: length expansion, area expansion and volume expansion, right? So we have to know how to calculate the expansion as well. That is the thing. You have to know the formulas, right? So these formulas will come to the exam questions, right? So you have to have the knowledge how you apply the values, and you'll have to remember the formulas as well, right? You'll have to you apply it more. More you apply, more you remember. That takes time. You can't do a paper like that, because better you do more questions or more applications. Huh? That part is good for the application. right? Understanding the theory, how it happened, how it construct, is good for the application. For to a formula to remember, best thing is you do more applications, so you'll remember it. Eventually, you will remember it. It will naturally come. You don't even have to take the energy to remind it. Ne? It will naturally come. It will all of a sudden will come. You think of the formula will come out. Likewise, it happens. It happens with the practice. So you have to experience more. That we'll see. You will be there. Don't worry much about it now. Right. Listen. Now the length increasing, or the linear expansion, right? We call the linear expansion. Linear expansion. Linear expansion, right? So the linear expansion happens like this. Let's say I'm taking a rod and I'm applying heat to it. And what happens to the rod now? The rod will increase its length, right? So if I take the initial length as L0 and this heated length, or the final length, as L1, the length increased, right? The amount of length that increased is what?
L1 minus
Exactly. That is L1 minus L0. I'll take the increased length as delta L. So delta L equals L1 minus L0. Understood it? Yeah. So this L1 minus L0, or the length increased, is directly proportional to the what? We are crying. Is it that hard? Huh? What? Not the heat provided. This length increase is directly proportional to what? Is directly proportional to the temperature. Yeah. Temperature. What happens when the temperature is more? The length that increases. What happens when the more temperature? The length that increases is more. Yes. More the temperature, more the increasing. Yes. So that is delta theta, temperature difference, is directly proportional to the increased length, right? More the temperature, more the increase. Second thing is, that is first formula, the first proportional. Second thing is L1 minus L0, or the increased length, is proportional to the initial length as well. This may be you don't know, but more the initial length. If you take a small rod and a large rod, giving the same amount of temperature difference, which one will increase more? The lengthy one will increase more of a length. It will expand more. Yeah. There is something practically done and proven. But just remember, lengthy ones expand more. Yes, simple, right? So there is 2. I'm going to take the 2 of the equation to 1 and 2. That will be L1 minus L0 proportional to L0 delta theta, taking the 2 of the equations to 1. Now what do we have to do now? I have to remove the proportion to make this an equation. For that I have to bring a constant here. If I multiply the whole thing by a constant, the proportion is converting into a what? Proportion is converting into equation, isn't it? Proportion is converting into an equation. So we can take the constant for this as alpha. Now try to understand, this is the proportional symbol, this is the constant. These are two different things, right? Alpha is the constant, this is not alpha, this is what? The proportional symbol, right? So this is alpha. Alpha times L0 delta theta. So I'm going to isolate the L1, which is the final length, right? So L1 equals taking minus L naught to the other side, that is L naught plus alpha L naught delta theta. Now L naught is common to the two of the factors that I am taking L naught out. That will be 1 plus alpha times delta theta. So L1 equals L naught 1 plus alpha delta theta. Understood it? Yeah. So you don't have to know how to derive it. You don't have to know how to derive it. Just the final equation is enough. There's another equation. I'll do it now. The equation you don't have to know how to derive it. Deriving it just for your knowledge. It's for you that you understand how it happened, right? That's all. So remember the equation, that is enough, right? And now this is the final length, right? Final expanded length or the final complete length. And if I want to find the amount that expanded, right? The amount that expanded, that is delta L, isn't it? So in the middle here, L1 minus L naught, instead of L1 minus L naught, if I apply delta L, right? If I apply delta L here, that will be what? Delta L equals L naught alpha delta theta. This is also one of the equations you have to know, right? Make it equal, right? Now here, listen, we have alpha here, right? We have to know what alpha is and what are the units of the alpha as well. So I'm going to isolate alpha. Listen, alpha isolated, that is delta L divided by L naught delta theta. So this is now alpha. So what does the alpha means here now? The length increased per initial length per temperature difference. Oh, a units වලට ගන්නකොට එහෙම. Now what does the alpha means? Length increased per unit length or the per initial length or unit length per unit temperature, right? So if I put the units here, delta L is in meters, L naught initial length is also in meters, and the temperature is in kelvins, right? Temperature is in kelvins. So now what happens to the meters? Meters to meters cancels out. So the final units will be per Kelvin. So the alpha we call the linear expansivity. The constant name is linear expansivity. So the expansivity, linear expansivity units are per Kelvin. Write down the whole thing in the first box. Wrote it somewhere else. Now write it again in the box. Derive करना है or not, that is for the knowledge, but derive करने विदियात लियला තියාගන්න, but don't study it. නෑ, write the whole thing. ටිකක් ඉක්මනට ලියන්න. Write the whole thing in the first box. ඒ කියන්නේ තේරුම් අරගෙන ලියන්න. ඊට පස්සේ define the terms as well. Can you define the terms? Alpha is what? Linear expansive. Sorry. expansivity. So what happens this is expansivity, right? It's linear expansivity. And delta is delta L length increased or the length extended, right? Length increased or length extended. L naught is the initial length, L1 final length, L1 is the final length. Delta theta is the temperature difference. Temperature difference. Temperature difference. Finish? Nice. Yeah. Guys online, I hope you are finished writing, taking the notes. If any of you want to take, have the screen on for few of the minutes more, like the whiteboard, the note, you tell me. Yeah? Now come to the exercise. Where's the exercise? Good expansion. This one. To come to the third question, try doing it by yourself. That is page number.
Last page.
Last, right? Try doing it. think a little bit, huh? You know the bimetallic strips? Bimetallic strips? Ever learned about it? Huh? Bimetallic strips. Bimetallic strips, not the, yeah. Huh? බයිමෙට්‍රික් ස්ට්‍රිප් එකේ පොඩි කැලලක් ඒ කියන්නේ බයිමෙට්‍රික් ස්ට්‍රිප් එක දන්නවනම් මේක ලේසි. නැවෙන්නේ ඒ හින්දානේ. ඒක දන්නවනම් මේක ලේසි. So that's it. Don't know. You're happy about it as well. Huh? Good. Yeah. Yeah. You don't know and you are really happy about it. Good. Peninja, can you remember biometric strips? Peninja thought something else. As is strips. You know it? Biometric strips, done it? For that biometric, there's like the two of the metals in the ions. You know it. Okay. Doesn't matter, you answer this. Guys online, shiny. Answer it. Think. I can make a shape එකකට නැවෙන්න ඕන expand වෙනකොට. ඒක තමයි අහන්නේ. That is the question. Found it? No, just a theory, you have to think. මේක S එක හැදෙන්න නම් alpha 1 කොහෙටද නැවෙන්න ඕන? right side. alpha 2 එකත් right side. alpha 3 එක left side. alpha 4 එක left side. ඊට පස්සේ expansivity difference එකක් තියෙන්න ඕන නැත්නම් කවුද alpha 1 alpha 2 වලින් වැඩිපුර නැමෙන්න ඕන? වැඩිපුර නැමෙන්න ඕන in the sense වැඩිපුර නැමෙන්න ඕන alpha 2, that is correct, yes. වැඩිපුර expand වෙන්න ඕන කවුද? Why? වැඩිපුර expand වෙන්න ඕන කවුද? ඒ කියන්නේ you have to decide which should have to have the greater expansivity to make it an S when it's heated. Think. Come up with a reason. Why? නැවෙන්න ඕන. නැවෙන්න ඕන. එතකොට තමයි S එකක් හැදෙන්නේ. කියන්නේ එහෙම වෙන්න මොකද්ද වෙන්න ඕන කියන එක අහන්නේ. What does your brain say? Not braining. Brain isn't braining. Come up with a reason. Why?
alpha 1 expanded on alpha 2 and all.
Why?
Yeah, S එකේ උඩ කෑල්ල දිලපු වෙන්නේ.
Hmm.
ඒ කියන්නේ
Hmm.
එහෙමනේ.
Because-
ඒක අමුතු ප්‍රශ්නයක්.
Right. It's a good question. No? Alpha 1 has to have a great expansivity than alpha 2. Why?
alpha 4 වැඩි වෙනවා alpha 3 වලට වඩා.
Hmm. Yes.
ඒක
So-
තුනෙන් උඩට.
Hmm.
එකපාරට අහන්නේ මේ කියලා හිතාගෙන ඉන්නේ.
ඒක හදා ගන්නවා. Right. So why and what is which should expand more, alpha 1 or alpha 3? Sorry, alpha 1 or alpha 2?
Thank you.
I'm asking again. You tell again. Why?
What's it?
Huh?
Ah,
Answer back again. I'm asking again for the people, for their understanding, bro. You're not the only person learning here. The others have to learn as well.
කියන එක.
I don't think they hear much. So you're telling it to me or to the others?
වංශයට කියන්නේ එනවා අනිත් අයට.
Thinking that they will hear as well. There's a few of the girls. Only one girl is now there, shiny. Right? Huh? He says using it as a way of what? Never mind. Right. Come to this. Right? So alpha 1 should be greater than the alpha 2. Right? Why? Because this has to, bend this way. Right? And when it's bending this way, this has a more radius than this one, isn't it? So one with the more radius has to have a more arc length, isn't it? Yeah. The one which is out, like the one which makes the outer circle, has to have more arc length than the inner one, right? So if I stopped it there, see, if I stopped it there, this has to have a greater arc length than this, isn't it? Now you listen to this, right? This has to have a greater arc length than to this, because it's the outer circle, has a greater radius, has to have a greater arc length, right, than this one. So to have a greater arc length has to have a greater expansion, right? It's the same to this. This has to rotate this side, and when it's has to bend this side, and this has to bend like this. So when it's bending, this has a greater arc length, isn't it? This has a lesser arc length. So to this to have a greater arc length, this has to have a greater expansion than this one. So always the outer circle has to have a great expansion. That's a simple theory, right? And it always bend towards the. Now, if you take a bimetallic strip like that, right, like two of the A and B metals, let's say B has a great expansion. To which side would it bend now? Upward or downward? B has a great expansion. Towards where does it bend? Up or down? B has a great expansion. Huh? Now this two bimetallic, like this is a bimetallic strip, two of the metal strips have different expansions. I'm telling B has a greater expansion than A. Towards which direction would it bend now? Upward or downward? Why would you say down? So B has a greater expansion means this length will increase more. This length will increase less. So that makes B the outer circle. Oh, it bends like this, isn't it? Yeah. So what if happened the other way around? This is A and B. Now the B has a greater expansion than the A. Right? A has a greater expansion than the, sorry, I said the other way. A has a greater expansion than the B. Now what happens? The A becomes the outer circle. So it bends this way with a greater arc length. Right, you can decide it. Understood it? Right. So Shiny found the answer for it. Now what is the answer here now? Alpha 1 greater than alpha 2. 1 greater than alpha 2. Only two answers there. And alpha 4 greater than 3. 4 greater than 3. Third answer. Hmm? Until I finish the class. How to? Stay waiting. How did? Understood it? Yeah? Okay. Now this guy is making it home. Doesn't matter, it's a good thing. You feel it like home. Then what? Right. So that's about the linear expansion. Apita passe, I think we'll take the next week to finish. Right, we'll take the next week to finish. Doesn't matter. So we'll finish it next week and we'll start a new lesson. Is it a new month next week? No, right? No. Isn't right? Is it? Oh, this Thursday. From 9:30 to 2:30. Is it a new month? Is it? It's a good thing. Then. So new month, new lesson.
No, we have the test back.
Huh?
Next week we have to like still finish this. Next week can we set?
Yeah. We are finishing in the middle, starting in the middle. Yes. Huh? Bro, you have the test. Yeah. Yes. We'll have the test here. Forgot it again. Oh. Right. So, people, you have a test next week. Yes. And week of next we'll start the lesson. Shit. Huh? Yeah. I wanted to finish the. Like a test. The force work. Yeah, the physics lessons. I will tell if I'm. Yeah, can include the heat as well. I'll tell if I'm including the heat. Huh? Heat is a bit different than the other lessons, but I'll consider it. So guys, there will be exam next week. Get ready for the exam, study well, do some good works. I'll see you there. Adios, you can go home. You want to go to somewhere else? Okay then. Anadura? Anadura? Payak kiyanne ithin that's a podi time man. Nice. Study well. Puthe එන්න කියන්නකෝ මේක ඔෆ් කරන්න. ඇත්තේ කාටද එන්න කියන්න ඔෆ් කරන්න. යන ගම කියයි. Just take a break.